So we learned how to clean the data last week, and in this video we'll do several things, but mainly we're going to look at the sample the data. The explore data we saw also last week allows us to see the distribution of the data. The clean allows us to do some binning. But what the sample does is it allows us to do several things. In the data mining Excel add-ins, the the tool itself will set aside training data for you, but if you wanted to do it by hand, you can do that here by clicking the Sample Data button. Yeah, I'm clicking Table so that it knows where the data is coming from. And I'm going to say Random Sampling. This is going to create two data sets. I'm going to tell it defaults to 70%. If I want, I can change it to 80-20. It depends. It's up to me to set those parameters, but I'm going to leave it with a default of 70%. So it's going to create two data sets, and I'm going to call the first one train and the second one test. So you see across the bottom now I've got a train data set and a test data set. I will build all my models out using the train data set, and then I will test them using my test data set. So I have now done by hand what is actually done within the tool in Excel. So let's build a structure. Once I have this train data and I have the test data, I can build out a structure. So I come over here under the advanced tools and I create a mining structure. I tell it which table to use, which columns to include. In fact, if I want to take some out, I can. It's going to ask us percent of data for testing. If I haven't split out train and test, I can leave that in there. But since in this particular example I've created my own test data, I can switch that to 0. And here's where I should take some care naming the structure. So I can say example for class structure. And I have the opportunity to put some documentation here, which is helpful once you've built out maybe several structures. Notice nothing's happened. If I want to see what happened, I can come over here under, I believe Manage Models, and I can see all my structures. And here's an example for class structure. What the structure is like a folder where I can add all the different models within the same structure. So if I'm choosing to use the same attributes, I've cleaned my attributes and I want to use those same attributes to try out different models, I can put them all within the same structure. So let's come over here and add a model to the structure. Let's add those models that we learned in class. So let's start with a decision tree. And we have to tell it that PEP is our prediction column, predict only. And here I have a chance to label my models and then also put some metadata on the models if I wish. So I have the output to the tree. I can look at it, but this isn't really what this explains things to me, but it isn't really what I'm after. I'm after to see how well it does in predicting and test. Before I go look at the classification matrices, I'm going to add another model to that same structure. So I can go look for my structure here. I know that it's example for class structure. And now let's add a logistic regression, which we also learned about in class. Again, I want to tell it that I want to predict PEP. I'll say predict only. Again, I get some information about how the variables each influence the model, but I'm really out after the prediction, though it's helpful to look at that. So let's add another model. Let's add a neural network. want to tell it predict only. Again, I get some output that explains sort of how those variables, but remember they're very hard to look at in neural networks. I'm going to add one more. We looked at naive Bayes, so I'm going to add a naive Bayes. Notice I get some do not use. It's going to say do not use because the naive Bayes doesn't like the continuous variable. So if I wanted to use age as a variable, I would have to bin age as well as income. So it's not going to want to use those. I'm going to go ahead and tell it predict. I get an output again. It only used 2 of the variables, so my guess is that naive Bayes is not going to do very well. So if I come over here, under manage models, I now should be able to see that in my structure I now have 4 models that I can evaluate. So I come over here to classification matrix, and that's how I evaluate the models. So in order to evaluate the 4 models that I have just built, I come to classification matrix, and I have the ability to select the entire structure and see the classification matrix for all 4 models so that I can compare them. I can also do it just for one of the models if I want, but in this case I want to compare the 4. We can look at the percent. I wanted to know that I'm predicting PEP, and we want to show the results. We can see the results as a percentage or a count, whatever you prefer. If you want, we can just change it to PEP. Notice that I get a message down here. In the case that I had let the tool automatically set aside the 30% of the data, then it would know where to go find it. But since I told it 0, I now have to tell it, hey, the test data is over here under test. It does a one-to-one column matching. In our case, the data comes from the same place, but had you used 2 data sets that maybe didn't have the same exact attributes named, this is how you would match them up. So now we've got the 3 classification matrices. It picks the best model for you, but remember, it's not the best way to do this. It's going to pick the best accuracy, but that is both for accurate, for predicting didn't participate as well as participate. So we rather look at the classification matrices. So by looking at these, it looks like really the bottom 3 are tied. Logistic regression, neural net, and trees, with naive Bayes not doing as well, which I predicted because I saw that it only used 2 attributes. And we can also look at how many mistakes I made. They are actually all pretty close, and part of the reason for that is that this data is pretty clean, so it doesn't have a lot of noise, and we actually didn't have to do much transformation in the variables.